solving equations like that. We'll start with one like this. This is an exponential equation. You don't see the word log, but you see an exponent has the unknown in it. So we want to get x, when we say solve, we want to get x by itself at the end, by itself, and find out what it equals. So we move the 5 over. And now I want to get x down where I can work with it, and rules of logarithms could do that, but there's no word log there. So I'm going to take the log of both sides. What log should I take? Since there's an e in the problem, I'm going to use ln. ln of e to the x equals ln of 55. Now, I know the answer to this side because ln is base e. What exponent do I give e to get e to the x? X equals ln of 55. So my calculator knows that, so it'll approximate it anyway. So we're going to get about, maybe line, or approximately 4.007. So what I need you to learn is what to do from this step to this step. So when the unknown is in the exponent, you want to work with it by taking the log of both sides. Let's look at a different one. Let's solve this one. 2 times 3 to the 2t is my unknown that I'm solving for, minus 5, that's an exponent, minus 4, that is not an exponent, equals 11. So the unknown t is in the exponent, and at the end of the story, I want to know what t equals. Notice you cannot multiply 2 times 3 at this point because order of operations, we have to do exponents before multiplication. So don't make that mistake. I'm going to add a 4 to both sides, and when we do that, we get 2 times 3 to the 2t minus 5 equals 15. Divide both sides by 2. What's 15 divided by 2? 7.5, 7.5, yeah. So 7.5. And now I'm at a similar spot where here, but I want to take a log of both sides, and the log that is simplest to take is going to match the base of the exponential. So the log, I'm going to take the log of base 3 of this, because that is easy to compute, and the log to the base 3 of 7.5. If I have to do the identical log but get to the same base on both sides. So what exponent do I give 3 to get 3 to the 2t minus 5? 2t minus 5. Now log to the base 3 of 7.5 is not on my calculator directly, but we just learned how to change the base. So I can do it as an log of 7.5 divided by an log of 3. So whatever that is, log to the log 0.75 or ln you could have used, and move the 5 over. This is still a 2t minus 5. But I'm going to move everything over at this step, so I'm going to bring the 5 over and divide that whole thing by 2 to get t by itself. So when I plug that whole mess in, I got 3.417. So that's an exponential equation and how to solve it. We'll end with a logarithmic equation. I'll just show you 2 of each, and you'll meet some other complications in class, which you will wrestle through, or I will push you through. So, in this one, do you recall this idea? We've seen that the log raised to e raised to the log base e of 17 this is the exponent that I give e to get 17. So if I raise e to that exponent, I will get 17. I call it the color of the White House because I'm raising the number that I raise a number to get 17, so it must be 17. Alright, so keeping that in mind is going to show up. ln of x equals 2 is my problem. I'm going to show you this way because it is more practical in other situations. You may think right away of a different way of doing this, and you may do it that way, but I want you to know how to do it this way. I'm only going to teach it this way. When we have a log, we can use this principle to get rid of it by what we call exponentiating both sides. So I'm going to create an exponent out of this, and I'm going to create an exponent out of this by doing this. This is also mathematically sound. I can take two things that are equal and put them into exponents when the bases are alike, and I still have two things equal. Why would I want to do that? Because I know this is base e, it follows this principle. I know e raised to the ln base e of x. It's x. So I get x equals e squared. One step. Exponentiating both sides. Alright, another one, and we'll call it ignite. Log to the base 6 of 3x plus 15 minus log to the base 6 of 5 equals log to the base 6 of 2x. Alright. In order to do logarithmic equations, to solve them, so we want to find out what x is at the bottom, we need to have a log of an expression on one side and log of an expression on the other. Log has to appear once on one side and once on the other. Here we see log is in two spots, and on this side once, which is fine on this side. I can use rules of logarithms to condense this, so I can rewrite this as log to the base 6 of this is called an argument. So whatever the log is applied to, or any function, is called the argument. So this is the argument, the only arguments I'm going to allow in class. So this argument divided by this argument. We know the log rule does that. So we can take two logs that are subtracted and write them as one log with the arguments divided equals log to the base 6 of 2x. Now I have log on one side one time, log on the other side one time. The only way these two expressions are equal is if their arguments are equal. So I can just extract the arguments and solve them. Multiplying both sides by 5, I get 10x, moving 3x over, I get 7x, dividing by 7, I get 15 sevenths. Alright, we're going to stop there for tonight, and hopefully you get all that down and be ready to use it. So I'll see you tomorrow.